Hello. Today we're going to talk about Topic 3, Section 7, the Circle Revisited. All right, so the first one is just converting from radians to degrees and degrees to radians. You could use a proportion and then just solve that. I like to think of it differently though. It's doing the same thing, it's just multiplying by one thing. So here we're given it in degrees. Hold on, let me change the color. Okay, so we are given the answer, the angle in degrees. We want to get rid of the degrees, so we divide by 180, and we want radians, so we multiply by pi. Okay, so 40 over 180, that simplifies, 4 over 18, which is 2 over 9. So 2 over 9 times pi, or you can say 2 pi over 9 radians. Okay. Then if it's given to us in radians, so we have 3 over 4 times pi. We want to get rid of the radians, so we divide by pi, okay, or multiply by 1 over pi. And then we multiply by 180 degrees. So you divide by what you want to get rid of, and you multiply by what you want. So the pi's are going to cancel. So then we have 3 over 4 times 180. And let's see, that should be 135 degrees. That looks like a 0. That's supposed to be degrees. Okay. All right, the next thing on this lesson was doing arc length. Now, what we did in a previous lesson was if you had it in degrees. Well, this is what if it's given in radians. So instead of using the proportion of degrees, okay, the arc length, that's supposed to be more of a cursive L, all right, is the angle in radians over 2 pi times the circumference. Well, so the 2 pi's are just going to cancel. So that's how we get the angle times the radius, okay, as long as it's in radians. Okay, so make sure you understand that formula. All right, so this one, we have a circle with radius 5 and radians of 1.2. So the arc length is going to literally just be 1.2 times 5. And that should give us 6. Okay, and that would be 6 centimeters because this is length, distance. All right, the next one is a circle with radius of 5, has an arc length of 8 centimeters, and we want to find the angle. So it's some angle times the radius has to equal the arc length, which is 8. So this one is literally just going to be 8 over 5 radians. That's the size of theta. Okay? Just understanding where the formulas come from. I think that's the important part here. Again, the same ideas here. We could use a proportion, right? The angle over 360 degrees. But if the angle is given to us in radians, we would do theta over 2 pi times pi r squared. Well, when you do that, the pi's are going to cancel. And so then you're left with that 1/2. Okay, so theta over 2 times r squared, which is the same thing they have here. That's the same thing as 1/2 times theta times r squared. All right. So here in our example, we want to find the area of a sector with central angle of 1.3. So the area is equal to 1/2 times r squared times 1.3. And here I'm going to get out my calculator. So let's see, times 1.3, I get 16.25. And if we're doing units, we're doing the area, so that would be centimeters squared. Okay. right, so for this example, okay, we want to find the shaded area. Well, I don't have a formula for some weird shape like that, but I do know that if I do the sector, so what's in red here, sorry, I can't trace very well. So the red is the area of the sector. That's a terrible T. Okay, so that is, remember, 1/2 times r squared theta. So in this case, it's 1/2 times 4 squared times 3 pi over 4. Again, only because it's given to us, the angle is given in radians. We know that because there is no degree symbol. Okay? If there's no degree symbol, it's in radians. So here we get, what should that be? 16, half of 16 is 8. 8 over 4 is 2. 6 pi. Okay. That is a terrible looking pi. Well, better. All right. Now, I would do the area of the triangle. So, the area of the triangle is 1/2 AB sine theta. So we do 1/2 times 4 times 4 times sine of 3 pi over 4. Now here, make sure that your calculator is in radians, because mine's been in degrees for so long. So don't just assume it's in the format that you want. Okay, so 3 pi over 4, and find the exact area. Oh, well then we need to use our hand trick. Okay, so sine of 3 pi over 4, that's square root of 2 over 2. So this becomes 8 times the square root of 2 over 2. Yeah, so 4 square roots of 2. So then the exact area of the shaded region, so this part right here, is the sector minus the triangle. That's our shaded part. All right, so the sector was 6 pi, and my triangle was 4 square roots of 2. And that's your answer. And that's everything you should know. So not a whole big section, but let's see. Hopefully that makes sense. Let me know if you don't understand.